Yes, this is Dr. Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology, Coimbatore. In the previous video, we have discussed about the classifications of feedback amplifiers. We have mentioned the classifications of feedback amplifiers. Now we are going to discuss about what are all the four types and how it performs in terms of resistance, impedances, and goes on. There are four types. One is voltage series, voltage shunt, current shunt, and current series feedback amplifiers. Voltage series, voltage shunt, current series, and current shunt feedback amplifiers. Before going to that, we again see here the amplifier part. The input is AC input signal, and the output is amplified in nature. You please see that the output is amplified in nature, whereas the same output part is given to the feedback element and it is connected to the input. And since there may be a positive or negative feedback, as per this is a positive feedback diagram, whereas here it is all are negative feedbacks or the positive feedbacks. Now see here, what is this? S. Okay. The first one is the voltage series feedback amplifiers. Voltage series. From the name itself, it is voltage. Therefore, the voltage is nothing but it is connected in parallel circuits. The voltage remains same. In parallel circuits, the voltage remains same. Therefore, for easily understanding the circuit, voltage, the first word, is nothing but the output part. The series, the second word, which is connected to the input part, remain connected in series. Therefore, the current comes into picture. Therefore, the voltage, see here, the connection, the output part is connected in parallel. The output of the A amplifier gain is connected in parallel, and this parallel connection is given as the feedback path to the beta. And whereas the output of beta is connected in series as VF. See here, it is connected as series in VF. Therefore, the output is shunted and the input side is series. Since the output part is shunted, it is named as voltage, and here the input part is series, which is named as the same series. Therefore, for here the voltage series feedback amplifier, the input resistance, since it is series, we know that for the series connection, when two resistors are connected in series, there is nothing but R1 plus R2. Since the two resistance, instead of two resistance, one is the resistance, input resistance, and another one is the amplification part of the feedback. There's nothing but 1 plus A beta, Therefore, when 1 plus A beta and the series resistance is connected in series connection, therefore it is R1 into 1 plus A beta. R1 into 1 plus A beta. This is the input resistance, input feedback resistance. Similarly, the output feedback resistance, since the output part is connected in parallel, we know that for parallel connection, the equivalent resistance 1 by R equal to 1 by R1 plus 1 by R2, the inverse. 1 by R1 plus 1 by R2 comes into picture. Therefore, here it is, instead of by R1, it is R0 by 1 plus A beta, the feedback part, 1 plus A beta. Therefore, the output resistance here is R0 by 1 plus A beta. You may please note that for voltage series, the voltage first term is in output part and the second word series is in the input part, voltage series feedback amplifier. Since the output is parallel, the output resistance R0F is R0 by parallel, therefore it is R0 by 1 plus A beta. The 1 plus A beta is the term, which is the amplification part of the feedback element 1 plus A beta. Similarly, for the input resistance which is considered in series, it is R1 into R1 multiplied by 1 plus A beta for voltage series feedback. I know that with this explanation we can easily draw the circuit diagram and you can easily derive the expression for the other three. The first term is for output and the second term is for the input. The remaining, it does remain same. The input Vi is the input voltage, Vf is the feedback voltage, and V0 is the output voltage which is connected to the load resistor RL. See here the next term, voltage shunt feedback. For voltage shunt feedback, voltage again it is parallel and shunt is again it is parallel. Therefore, both the sides of the single stage amplifier it is parallel. Both the sides of the single stage amplifier is parallel. Therefore, the expression is R input resistance, again it is by, and output resistance is also divided by. Input resistance RIF equal to RF divided by 1 plus A beta. Similarly, for R01, it is R0 divided by 1 plus A beta. Now, let me see the next two. Again, the next two. The current shunt. As per the name itself, the first word it is a current, which is nothing but connected to the output. The second word it is shunt, which is nothing but connected to the input, parallel. Therefore, since it is current shunt, see here the current is the output part. Therefore, R0 F, current is in the output part, which is nothing but series. Therefore, R0 F equal to R0 into multiply. R0 F equal to R0 into 1 plus A beta. Similarly, the current shunt, the shunt is in the input side. Therefore, in the input side, RIF equal to R0 divided by 1 plus A beta divided by. Similarly, the next fourth type, current series feedback, both are series. And the input and the output are series. Therefore, there is no divided by expression comes into picture. RIF equal to RI into 1 plus A beta. Similarly, R0 F equal to R0 into 1 plus A beta. Whereas, from the four types, the expression is given: the voltage shunt, the current shunt, the voltage series, and the current series. The effect of input resistance on the output resistance, again it is mentioned here. And now all the summary of the all types in terms of resistance. If an AC signal is given, then you have to replace this R into Z, impedances, input impedance and output impedances. Whereas from this discussion, for an voltage amplifier, you mean you have to amplify the voltage signal alone. Voltage amplifier. The voltage shunt comes into picture. It is an voltage amplifier. And current series, so nothing but the current amplifier. And current shunt, which may be current shunt, you mean I by V. It may be trans conductance. I by V, which is nothing but trans conductance, and V by I is your trans resistance amplifier. Therefore, current amplifier, voltage amplifier, trans resistance amplifier, and trans conductance amplifier comes into picture in all these four types. Hope you understand this four types of feedback amplifiers. Thank you for patient listening. Thank you very much for seeing this video series.